in this episode, DI method, a shortcut for integration by parts. Coming up, back into action. Hey guys, in my previous episodes I did integration by parts, and to be perfectly frank with you, it works well, but it takes lots of time, since sometimes you have to use the integration by parts or UV formula more than once. Sometimes you should apply it twice or three times, and it takes huge amount of time. Well, there is a sure way, a shortcut for integration by parts, and sometimes it's called DI method or tabular method. So DI, D stands for derivatives and I stands for integral. Well, there is one little thing, one little remark that I would like to point out at this point, that unfortunately DI method does not work for all types of functions and integrals that you are given, but still it's worth to try it out. So just let's have a look. Suppose you are given this integral. Well, first of all, we begin by constructing the table, DI table, and the first column of your table is gonna be D. So D stands for derivatives. The second column in your table is I, which stands for the integral. That's why this method is called DI method. Now, in your first column, in your first row, you're going to place one of the component of your integrand. What are you going to put here? You're going to put x, and the reason is because x, the derivative of x, is just 1. It's easy to differentiate, and as a good rule of thumb, you want to place in your D column whatever function is easier to differentiate, because basically we're going to differentiate it repeatedly a few times in order to get 0 at the very end. So this x goes into this first column in the first row. And if you look at this as a u and v according to UV formula or integration by parts, so this x has to be picked as a u if you apply UV formula straightforward. So whatever you pick for your u, if you use UV formula, goes for your D column. So the rest, namely cosine x, that goes for your I column. And just keep in mind that this term we're going to integrate, so also we want to make sure that we will be able to integrate. So again, it's kind of, I would say, tricky part. It's very similar to what we do for integration by parts, when we pick your u and the rest, what's left over, including the x, is gonna be your dv part. So this is as well, but again, it takes time, and the more you practice, the more get skilled. So now the second row is gonna be just the derivative of x, which is 1, and the second row for the second column is going to be the integral. So the first column, we differentiate your term. The second column, we integrate. So the integral, the entire derivative of cosine x is just sine x. Now, you repeat this process until you get 0 over here. Well, as I said before, sometimes it's impossible to get 0, so you might try something else, or you might just get to UV formula, integration by parts, straight up at this point. So now, since the derivative of 1 is 0, we are done. And at this point we are going to stop. And the entire derivative of sine is negative cosine. So I'm going to write it over here. So negative cosine x. So again we integrate and we differentiate. Now, we're almost there. One little thing that requires to be here. On the left side of this table, I'm going to place the signs. You always start with plus for the first term, for the first row, and you're going to alternate them. So for the second row, it's going to be minus. And for the third row, it's going to be plus. So if you have more terms go down, you just alternate the sign. Again, you always start with plus, minus, plus, minus, plus, minus. Always alternate between positive and negative. Now we're almost done. We're almost there. And you will see how fast this method is. All you need to do is just take your first term and you take this diagonal and you're going to multiply this term by this one. And the sign of this product is going to be plus. And you could write it as your answer. So x times sine x. And this entire term is positive since we have positive over here. Moving on, for the next one, I'm going to take this one and I'm going to multiply it by negative cosine x. So again, you multiply your diagonals in your table. But because this row requires this negative in front, so this product has to be taken with negative. So it's negative 1 times negative cosine x. Well, you could just ignore this one. I just write it explicitly in order to see from where all these things came from. And we are done. Because whatever you have further, whatever you have down, since you have 0 over there, so 0 multiplied by anything would just give you 0. So whatever you have, it doesn't matter, wouldn't matter what you have down. So all these terms, they just become 0. And all you need to do at this point, just add your best friend, add the arbitrary constant of integration, c. Now just clean it up and simplify it down. So you just rewrite your first term as this, x times sine x. And this one overall becomes positive, it's just cosine x plus c. This is your final answer, general solution, general integral for that problem. So again, one more time, if you have more terms until you achieve 0 here, you just repeat the process. You just multiply these diagonals straight across, and also along with alternating the sign. And it could be more than 2 products, it could be more. If you cannot reach 0, you could take the integral of the row, the last row basically. But this is a little bit another story, and that's coming up. I hope it helps you guys. So thanks for watching and train your brain. I know everyone hates maths, but if you like my video, please share with your friends, hit like, leave the comments down below, and be sure to subscribe so you will not miss out my new videos.